Hey everyone, welcome back. Up to this point, we've been learning the basics of JavaScript, things like data types, variables, operators, and type coercion. These topics help us understand what JavaScript can do and how it behaves when we write code. But knowing the basics is only the first step. You can write code that works perfectly and still have the code that's confusing, hard to read, or difficult to fix later. This is something every beginner struggles with, and that's completely normal. That's why in this video, we are starting something new. We'll learn how to write clean and readable JavaScript. This is the first time we are focusing on not just making our code work, but on writing code that makes sense. Code that you can come back to later after a few days and still understand. Code that other developers can read without feeling lost. In this video, we'll talk about simple habits and best practices that make our JavaScript easier to read, easier to maintain, and also easier to improve as you keep learning. This is where your code really starts to level up. Quick disclaimer before we start. This video is going to be a bit lengthy, but that's because clean and readable code is really important, especially as a beginner. I recommend watching it at your own pace, and you can always pause or rewatch sections as needed. Let's get started. So, how to write a clean code? We have certain things to focus on while you're writing code, and we'll see one by one. First, meaning of what is the meaning of clean and readable code? Clean code is a code that is easy to read, easy to understand, and easy to change. Readable code explains itself through structure and naming, but not comments. So we'll see an example. So we can write an expression like x equals to 5 multiplies 1.2. Let's look at this example. In this line, we have let x equal to y times 1.2. This code technically works, but it's hard to understand. We don't know what x represents, what y is, or why we are multiplying by 1.2. If someone else reads this code, or even if you come back to it later, it won't be clear what's happening. Now, let's write this in another way. So we'll call our first variable x price with tax and variable y as price, and we'll multiply it with. Now look at this. So let price with tax equals to price multiplied by tax rate. Just by reading this, we can understand the intention. We know we are calculating a price with tax. We know what the original value is, and we know that the tax value comes from a named constant. Both pieces of code do the same thing, but the second one is clean and readable because the code explains itself. That's exactly what we mean by clean code. You might notice that tax rate is written in capital letters. In JavaScript, this is common convention used for constants, values that are not supposed to change. Writing constants in uppercase makes them stand out immediately. It tells us anyone reading the code that this value is fixed and should not be modified. So when you see tax rate, you instantly know it is an important unchanging value used across the application. This isn't forced by JavaScript, but it is widely accepted best practice, and that this improves readability and prevents accidental changes. Next, we'll see another example of consistent naming conventions. So there are several naming conventions like snake case, Pascal case, and camel case. Just pick a style and you use it everywhere in your code. So in JavaScript, we usually use camel case. I'll show you what camel case is. Before that, yeah. So let's see camel case. Let's see this example. So it has three words. I have three words here: price with tax. So the first word, the first letter of the first word will start with a small letter, and next every word will start with a capital letter. So we'll see some examples. So you can declare a variable like this, and then you can declare another variable like this. So you're using different conventions here. You're using snake case here, and you're using Pascal case here. But in JavaScript, we use camel case, and we also need to be consistent with it so that it does not create any confusing. Instead, we can write our names like so. So the first letter of the first word always small, and the first letter of every other word capital. And the next one. So this is consistent, and this is here you are being inconsistent. You are having one case here and one case here. Both of these examples work in JavaScript. JavaScript doesn't care how we name variables. The problem is for us as humans. Like when naming styles change from snake case or camel case or capital letters, it becomes harder to quickly read and scan the code, right? So you using one consistent style like camel case makes code predictable, and once your eyes get used to the pattern, reading becomes much faster. So try to use one case throughout your code. And the next one, meaningful variables and function names. So you saw here. So I can write x and y, but again, you won't be able to understand. You need to check for the entire program, to see what's happening here. But uh, so we'll say this is a bad example. Let be this is a bad example of writing variable names or function names. So a good names are something like we can say days remaining. Right. So we clearly know that what this variable means, right? And also instead of writing function names like this, you can write the same function. You can write something like this. So again, JavaScript is perfectly fine with short variable names like this. But as humans, we don't know what b means without extra context. When we rename it to days remaining, the variable explains itself. No comments are needed. Clean code reduces the need to remember things. Your code should do the explaining for you. So so in this case, we'll be writing comments such like this. So these are is days remaining, something like that. So if we write our variable names clearly and meaningful, we don't need to add unnecessary comments. And the next one, small and single purpose functions. Each function should only do one thing, right? So we can have a function, let's call it user, handle user. So we can have a function, and we can ask this function to perform, how to validate user, and we can also make this function to perform save user, and something else like send email. So we can have one single function, and we can write code, to do all these things. This again, this does not create any bugs in your code, but this is not a good practice because it your function is doing too much. Instead you can create a single function for each functionality. So you can save user, send emails. So again, this function works, but it's doing multiple things. So if something breaks, it's harder to tell where the problem is. If it, you need to debug everything, like you need to see everything. But if you write something like this, three functions for three different functionalities, then if something breaks, you can quickly understand where the problem is. By splitting logic into smaller functions, each function has a single responsibility. So this makes testing, debugging, and reusability much easier. And the next one, proper indentation and formatting. So I can write, let's say there is an if block. So we are checking for if the user is logged in. right? If he is logged in, we want to do something. We want to do something, but we don't have proper spacing in this. Again, this does not affect the functionality or the behavior of this if block, but it becomes hard to read. So if we write the same code like so, right? Yeah, like this with the proper indentation, it looks good, and this is also like readable formatting reduces mental effort. JavaScript ignores spaces and indentation, so this code will still sorry run. But without proper formatting, it's harder to see where block starts and where block is ending. Indentation is visual communication, so it helps us understand structure at a glance. But VS Code, coming back to VS Code extensions, regarding this formatting, Pretter helps a lot, because if you miss spaces, or while writing the code, it is harder to keep track of the format. Just when we save the file, Pretter does everything for you, but you need to keep in mind that you need to give proper indentation, and you need to format your code so that it is easy to read. Avoid The next one is, we need to avoid deep nesting. So too many nested if statements makes code harder to follow. Example. So if you have something like, if user exists, so if there is a user, then you need to check for if user is admin. Then after that, if he is admin, then check if he is active or not. If he is active, then allow access. So again, there is nothing wrong with this code. It still works, but it is hard to follow, right? So let's write a better version. If user is not logged in, or this is logical or operator discussed in the last video. If he is not admin, right? Or if he is not active, then we just return. We just return, right? So instead of checking one by one, one by one, this is checking everything in the same line. So it checks for this. Then if it's true, so in this case, if he exists, then it will check if he's admin or not. If he's admin, then it will check if he's active or not. Then it will allow access. In this, it will check if the user is there, like if he's not there. If he's not there, it will return. If he's not admin, again it will return. If he's not active, it will return. Because any of this condition fails, it will not allow access. So we are giving all three conditions in the same line. So any of this condition fails, it will return. Wait. Yeah. And now we can allow access. Right. So this is again easy to read. It's not that hard to follow. This logic is correct, but this deep nesting forces our brain, to track multiple conditions at once. The more nested your code is, the easier it is to miss something. And flattening logic improves readability, and it reduces mistakes. And the next one, again, this we have, a few points to you know keep in your mind while you are writing code. I'm trying to explain everything. I can everything. So this video will be a little bit lengthy. Try to you know go slow, focus, and try to remember everything. Understand everything first. Then some points here are dependent on one another. So if you keep one in mind, then it's like you will automatically do the other thing. So just try write some code, try to apply these to that code, and if not in VS Code, try to write in some text editor like a notepad or something like that, and then try to apply these things so that you learn these things using let and const correctly. This we have discussed when we are discussing about JavaScript variables, but again, this is also one of the best practice. Use const by default and use let when only when reassignment is needed, right? So, what example we saw here? Tax rate. So tax rate is a constant variable. Do something like tax rate equal to, let's say, 0 point, and let total equals to 0. Why? Why total? Why I used let for total? Because total is a value that is 0 for now, and I know that it is going to change after I do some calculation. Let's say after some time we do some calculation like total equals to total plus 7. So I know that I'm going to do something with this variable. That's why I use let here. But I don't want this to change because tax rate is going to be same for my code. I know this. That's why I used const here. This makes your intent very clear. JavaScript lets you use let everywhere, but using const by default is a signal to other developers. It tells them this value should not change, and this makes your code safer and easier to reason about. So clear function parameters. Again, this is also something like meaningful variable names. Again, when you are passing parameters, try to write some meaningful names. So if we can write something like this, and so this function is expecting three values. We know that, just that, by seeing this. But if you write the same thing, if you have like this name, age, and email, so this works. This works, but we have no idea what A, B, C represents. And clear parameter names make function usage obvious and reduce mistakes when calling the function. And if you have too many values, you can use object like so. So when a function needs many related values, passing them one by one can become confusing. For example, passing name, email, and age separately means you have to remember the correct order every time you call the function. Instead, we can pass single object that groups all related data together. In this example, the function is expecting an object, and we immediately destructure it into name, email, and age. Again, JavaScript doesn't require this, but this makes function easier to read, harder to misuse, and more flexible if we want to add more values later. And how we can pass these arguments as a value, an object, we'll discuss when we are dealing with functions. But just remember, this is also a best practice. Comments: when and when not to use. Use comments like to explain why, but not what is it. Just remember this one rule. You if you want to explain like why this is there. So, for example, so your do you have an expression something like this? You don't need comment here, like add one to count. You don't need it because it is obvious that you are adding one to the count. But at the same time, this comment does not add any new information. The code explains itself, right? Comment should explain why something exists, not what the code is doing. Let's see. We'll have an example like, so we have a function called like this. So now we can add comments like, so this when we read this comment, Retry once because sometimes API fails. If you read this, we are understanding that we are trying to send a request to an API. If it fails, we are trying to retry the request. This comment is very clear. Like once we see this, we don't understand like why it's there, but this helps us. So clean code needs fewer comments. So that is what I'm saying. Like we can add comments everywhere. So here we can add comments saying what is what. Again, we can add comments here also. But if we write clean code, if we follow these practices, then we don't need to mention unnecessary comments. Uh, we can limit our comments to a minimum amount. Avoid magic numbers and strings. I'll tell you what. These hard-coded values are confusing. So let's say we have something, we have an if condition, like we have an if condition which says status, which is comparing status is equal to 404. The number 404 works, but its meaning isn't obvious to everyone. Like we don't know what it actually means. So instead, we can do something like this. Instead of this, we can write a variable. So this is naming this. I'm naming my 404 to a variable called not found. This naming gives it context and make the code easier to update later. So try to reduce using again magical numbers or strings. Means if you directly hard code numbers, you know people will not be able to understand it easily. Drive principle. What is drive? It is do not repeat yourself. So if you have if you have something a function, like let's say if you're writing an expression and you are doing the same thing again and again. So let's say you have an expression like this, and again you have something like again you have something like this. So here you're doing something very similar, but the values are changing in these two statements. So instead of repeating yourself, you can create a function called add tax. We can call it add tax, and we can pass it. We can pass the amount, and we can return amount times tax. Right? We can do something like this. So we can calculate the total, and we can pass the total, or even better, like we can pass directly the price or the discounted price, and we can do something like this. So if we want to do it three times or four times, we can just pass the price or the discounted price or selling price or cost price, whatever, to this function, and we are just writing the code just once. So in this way, we are not repeating logic. Again, repeating logic works, but if the calculation changes, you have to update it everywhere. Like so, if I'm trying to you know add something else, like from the total, I'm trying to multiply. See, sorry, I'm trying to subtract one from this total. So if this calculation changes, then sorry. So now I have to update my every expression. Let's say if I have five expressions, then I have to put -1 everywhere, right? So in this case, I can just put -1 here. Then I can pass the. I don't have to make any changes anywhere else. So this is what drive principle. Do not repeat yourself. And when you should not repeat yourself. So if it's one time, it's okay. Means you just have two statements which are similar. Then it's okay. You're doing it like three or four times throughout your code. Then it's better to write a function for that functionality. And readable conditionals, which is similar to this one. So see this. So we have a conditional statement, but in that conditional statement, we can understand everything, right? This is saying if user is exists or not. This is checking if user is admin or not. This is checking if user is active or not. If we write the same thing, so if I write the same thing like this, so user user admin, uh, let's call it something else. User active or something. Yeah. So let's see if user is blocked in this case, right? You can write like this again. JavaScript is in this condition is valid, but it's very hard to understand and read. Using this meaningful names, using these meaningful names, turns logic into readable sentences. We can read this and we can easily understand what's going on here. What that condition statement is checking for, and early returns. So we'll write a function, and what it is using is saving save. So we are passing user to it again. If user, just copy this one. So if user then is admin, then you know we are saving. We have a function like this. See, again, nothing wrong with this function. But so we changed this to this one. So instead of going through all these if statements, we have a written here. Then if this fails, then we are allowing access, right? So so this checks for everything. Then it goes to allow access. Instead, before even going to this step, we are adding a return statement here so that the function terminates then and there if any of these conditions like or all of these conditions fails. This is our early statements. We let's say we have a function checking for an Armstrong number, or if we are checking for the number of characters, in a string, or the frequency of a single character throughout the string. We have a function and we have a return statement at the end of the string. Like we are checking for the characters and then we are returning the count of the maximum character. But if we add a base case and if we have a return statement and in the starting function, but if so we have something like this and we are returning count here. So don't bother about these things. So we have, let's say we have some 7 lines before that. So even if you pass empty string, the entire function will be executed and then we'll return the count. Instead, we can if we pass empty string, we can have something like if string dot length. So for empty string, length will be 0. Then return, right? So what will be the count? 0. Count will be 0. So if you have a statement, early written statement like this, then the JavaScript does not need to read the entire function. It receives the string, empty string. It checks if the length is 0 or not. If it is 0, then if the string is, it understands the string is empty and it will return 0, and it doesn't need to read all the function. Understood? So that's how early written statements help. And destructuring for clarity. What is destructuring for clarity? What is destructuring actually? So if you have an object or if you have an array, so we have array elements and we have an array called user, and in that user we have a name and age. Now because this user has two values, now we can use name and age throughout our code, but we don't need to access something like user of 0 and or user of 1. We don't need to access it like this everywhere inside function. This is called destructuring. So first I'll show you how our user is. So user is something like Alex, and age 25. So our user is 25 and he's Alex. And so I destructured my both elements like this. So now whenever I want to use uh, name, so I can access name like this, and I can access age like this. Otherwise, if I don't use destructuring, still I can access, but it will be clumsy. So user of one. Again, when we are dealing with arrays, sorry, yeah, when we are dealing with arrays, we learn about destructuring when we are dealing with arrays and objects. But for now, understand destructuring makes it clear with which properties are actually uh, about, like what these properties actually mean. We have we have properties in array. You know what these elements actually mean, right? Without destructuring, again the code still works, but destructuring reduces repetition. User of zero. We don't need to repeat it. Okay. Consistent file and folder structure. This app will run no matter how the files are organized. So, but human relies on structure, predictable. So let's say when we are building APIs, we have several components, we have some utility functions, we have some routers, we have different folders. I mean different files. So if I have something like components, let's say we have a folder like this, and then in that folder we have a button component, and we have a header component, and then we have another folder called util. In that we have format date, a function, format data function. This is very clean and very clear. This is predictable. So if something is not working, it is easy to debug. You know where the problem is, or it is easy to understand. You know which file to check. But if I have one folder called, let's say, I'm building an app called React using React, so I'll call it React app, and instead of like this, I'm putting all the files. Let's say I'm putting all like my 20 to 25 files or some everything in one folder. Now I don't know what is what. I don't know which one is component, which one is a function. This still works, but it is not recommended. So please use a consistent file and folder structure. If you can see, I created folders like for each class. So now, if I want to go or access or check any file, I can directly go to data types or operators and expressions or type coercion. I can access any file. But without it, or if all my files are here, I wouldn't understand which file to check. Now, error handling responsibility. Error should be clear and meaningful, right? So let's say something like we have try block in which we are trying to fetch user. If we can't fetch, we have a catch block, and like if this is like if we get an error, so we'll try to console log an error, and the error should be clear. What is the error? Failed to fetch user data. Again, so you need to error should explain what went wrong. Yeah. Clear error messages make debugging faster and less frustrating. So if I just put here error, error, and I'm trying to fetch my user. I know there is an error, but I wouldn't understand what the error is. But this, so I need to check everything to understand what actually went wrong. So try to write clean and clear error messages using modern JavaScript ES6 plus. So we'll see what is the difference. So this is old way of writing a function. So we have two parameters, and you're returning the sum of those two parameters, right? This is old way. I'll show you new or modern. So we have a constant variable called sum, and that sum we are equating it. We are assigning a function a plus b. So this is how we write arrow functions. We'll discuss more about this while we are dealing with functions. But for now, remember this is also doing the same thing as this function. So it is returning. It has two parameters a and b, and it is returning a plus b, and the return value is stored in the variable sum. So use arrow functions, use destructuring, and use template literals. Template literals is something you can format your string so that you can directly incorporate your variables inside your string rather than writing them separately. Using string concatenation. These are the modern ways. So older syntax still works, but modern JavaScript is more expressive and readable. It helps write less code and with clear intent, right? Always prefer code consistency over personal preference. So I want to write a variable. Let's say again total price, and I want to declare another variable. So right, there is nothing wrong here. So it is understandable. Like I can understand this. I can understand what this variable is and what this variable is, what they are doing. But this is not about personal preference. This is you need to be just consistent. This styles like this is one style of writing variable names, and this is another style. JavaScript allows many styles, but teams need consistency, because just because I'm understanding this, that doesn't mean the person who is working with me should also understand this. So if I'm writing total price, and if I want to create another variable, then I should use the same naming convention, but I should choose a different variable name. So this consistency code is easier to read than code written in everyone's personal style. And the last one, and yeah, we'll see why we need to write clean code. So refactoring. What is refactoring? Refactoring is improving your code without changing the behavior. So I wrote a function like so. F of x. What is this function doing? Returning x multiplied by 1.2. Again, nothing wrong with this code. This still works, but I wanted to change it. I wanted to refactor it. Refactoring it means making some changes, but not losing functionality. So something like I want I want to calculate price with x, and x is my price, and I am returning price multiplied by tax rate. So both of these functions does the same thing. I call f the function f, I call function calculate price with tax, and I pass my price. Both will return me the same value. But this clean code is about long-term understanding, not just working today and getting the job done. That's why you always need to try and refactor your code. And again, once you're done with your code and it's working, if you take some time and try to refactor your code, if you try to apply all these practices to your code, it will make your code much cleaner, easier to understand. So, and you'll also see if you are using any variable that that can be you're repeating, or you're using unnecessary variables. So here let's say example. So let's say this, I'm storing my value in this variable, and in the next step, say this is just an example, I'm returning this sum. If if I'm spending some time to refactor my code, so after that I would understand that I don't really need this new variable. I can directly return it like this. I can directly return it like this. So it makes your code, you can reduce lines, number of lines from your code, and you can also make your code much cleaner if you refactor your code. And why clean code matters. So clean code, again, I told you many times over this lecture, but clean code is easier to debug, it scales better, and it helps teams to collaborate, and it also saves time in long term, right? So code is read more often than it's written, because you are writing your code once, but if three people see it, then three people are going to read the entire thing before making any changes, right? So JavaScript doesn't judge code quality, but real projects do. Clean code reduces bugs, helps teams collaborate, and makes scaling possible. This is all about how to write a clean code. And to wrap things up, clean and readable code in JavaScript isn't about writing fancy and complex code. It's about writing code that makes sense to you today, and to you or someone else in the future. With this video, we have now completed the JavaScript basics, from data types and variables to operators and type coercion and writing clean readable code. In the next part of the series, we'll move into control flow, where JavaScript starts making decisions. And in the very next video, we'll begin with if-else statements and see how logic works step by step. Thanks for watching. Take your time to practice what you've learned, and I'll see you in the next video. Again, if you have if you feel like you learned something from this video, like, share, and subscribe. Thank you.